Hello, I'm Layne Hartsell with the Korea IT Times, and I'm here with Oliver Sampson, a computer scientist in Lake Constance, Germany. Welcome. I just wanted to say that Ollie's a computer scientist and an adjunct lecturer there at Lake Constance and has been a longtime friend. We've known each other probably since we were, well, I don't know, children anyway. Went to high school and
Yeah,
to
at least since high school.
high school and Virginia Tech together. And
Yeah,
we've kept in touch, and I've always been impressed with Oliver's abilities, particularly in high school. Probably the smartest guy in my high school, probably the smartest guy in the whole area. Welcome, Oliver.
thank you. Thank you for having me. It's nice to be here.
I'm giving a lecture this week in Bangkok. The topic that I'm looking at is ontology, the ontology of the self related to an ethics in AI. So today I wanted to talk to you, and we had already discussed this earlier, but I wanted to go into this publication in Mind, the journal Mind by Alan Turing in October 1950. And he starts off in the first paragraph called the imitation game. And he proposed, I'll quote him, I propose to consider the question, quote, can machines think, end quote. And then he goes on to talk about the quote machine and what thinking means. And then of course the conclusion and the answer to this type of inquiry is it's really useless because do we say that or do we ask that submarines can swim? So there's a bit of an ontology here. There's an aspect of linguistics, and then there's a danger of turning human beings or putting human beings into a machine model, similar to what Skinner tried to do with human beings and behaviorism. So why don't we start off with this Turing paper and let me get you to comment on what you see, in that part.
Sure. Well, so the Turing paper, the imitation game, of course, now very famous because of the movie, and very famous because of the advent of large language models and the idea of trying to see if these large language models are capable of things like thinking or reasoning or whatever the marketing hype is currently going on with respect to these models. So this is all very, very current thinking and talking. So I think your talk is going to be a smashing success. So the issues with this is that we ask questions like, can a machine think? And so then we have to decide, what does thinking mean? Do we have definitions for thinking? We all know what thinking is. We think and we have thoughts, and we talk about our thoughts, and we're able to communicate things that we generate in our heads. We can communicate them through different ways, through language, through drawing, through writing, through singing, whatever methods of communication we have. And so and we ask these devices in this age of, we'll use AI, but it's a bit of a marketing term also, and especially with respect to generative AI and these large language models. And we ask, what does it mean to think? And I don't think anybody has a real, concrete, measurable type of yardstick that you can use to slap on a large language model and say, yeah, we've got 80% of thinking, we've got 100% of thinking, or even 120% of thinking, or something like that. We don't have good definitions. It's very difficult to define things. What does even intelligence mean? Does thinking sort of implies a type of intelligence? So if it's thinking, is it thinking slowly or poorly? Therefore, it has a low intelligence. Is it thinking quickly and masterfully? Therefore, it has a high level of intelligence.
Mhm.
And even then, you get into sort of like this idea of reification of intelligence, the
Mhm.
whole fallacy of IQ tests
Mhm.
involved in that. So I think the fact that we have these devices, large language models, that are capable of generating thousands and thousands of tokens of what looks like reasonable, grammatically correct language is really a fantastic parlor trick that leads us to believe that this device, which is able to do a trick that makes us think that it is thinking, because one of the ways you communicate thinking is through language. Um, it tricks us into believing that there's this thinking happening when there is absolutely no thinking. It's just a probabilistic token generator. So it's a very exciting time to be
It's
involved
exciting.
in this. Yeah, it's amazingly exciting time for it to be involved in these things. But we have until we try to get a better understanding of what it means to think, what it means to express intelligence, what it means to have what this thought process, or these things that are happening in the background. I don't think that. I think the question is almost ill-posed, because
Yes.
we're implying that this device has a capability, which is the type of anthropomorphism of the device, where it has a function that we imagine is actually a capability. And I believe that is completely ill-posed, and not really what how they actually work. So
What's interesting is that
um,
as I heard you right there at the beginning, you seem to say that there's not even any compass within this thing. Like we can't say this is up and this is down and this is high or this is low, it sounded like, you know. I mean,
I
how do we
well, I
determine?
mean, I
Yeah.
think that so communi communication, everything. So let's try to think that everything comes down to communication. So communication from an information theoretic point of view involves encoding and a decoding. You have a sender and a receiver, and there's a message, and the message passes through a medium, and then so hopefully I am successfully encoding whatever my thought process is through the English language. It's going through a whole bunch of electronics and several thousand kilometers to get to you. You are listening to me, and you are hearing it, and you're decoding it. And we have just completely, we've performed a fantastic information theoretical experiment of communication and ideas, and this process. But a lot of that is, so when in the case of when we speak, we have the it's possible to miscommunicate, where perhaps I have encoded the message incorrectly, or I have used words in a way that maybe they aren't supposed to be used, or there's an error on the decoding side, where maybe you mishear what I say, or you misinterpret what I say, and then the message that I intended to have being delivered is somehow construed incorrectly on the decoding side,
Okay.
right? So now let's apply that to large language models. They, through a prompt, generate some body of text, and this text is given to me, and I am decoding. So it has been encoded essentially by a large language model, and then I am decoding it. And then everything that I am doing, I'm reading into this. I am the act of what this sort of you model as intent from the device is not the intent of the device. It is the reading happens inside my head. I am the one who is imposing this type of intent and ability on this token generator, where there is no intent involved. And so
Right.
and there's a whole bunch of smoke and a whole bunch of noise, and coming from the coming from the the marketing side of large language models, saying, yeah, these are thinking machines, and these are reasoning machines, and we've trained them to be able to parse out tasks and create subtasks and complex problems, and so on and so on and so on. And no, it's a probabilistic token generator, and there is no intent. It is trained through millions of dollars and thousands of kilowatt hours, maybe millions of kilowatt hours, in order to be able to create a model that generates the next best token. And then when we read that, we impose our anthropomorphism, our ideals of what we suppose may be behind this text. But it has nothing to do with what's actually in the text. It's all about what's in the reader's mind that's happening. So
Right.
um,
It's a highly sophisticated, like word suggestion, like when you're typing in and the words, like in the URL or something like
Yeah,
that?
yeah, you know, I think it's very fair to call large language models spicy autocomplete.
Right,
So,
right.
it's just autocomplete on steroids. And I mean, I really want to actually underscore one thing. The Even though it is just spicy autocomplete, the fact that they are capable of generating thousands and thousands of tokens that are coherent, natural language,
Yeah.
really correct sentences, correct grammar. This is truly magical.
Yes, it's
These,
magic.
10 years ago, even
It's magic.
before, yeah, it is very, very close to this is truly amazing. 2019, 2018, no way. No way. The best we had was, you could get 10, maybe 15,
Yeah.
20 tokens of coherent speech from very complex models. But it wasn't until, we had the LSTMs, and they did pretty good jobs of types of sequence to sequence and so on. They had the sort of memory thing going on, but they weren't really good. Of course,
Right.
it was only until the attention is all you need paper came out that they became very, very good in what we understand as large language models today.
When you say
But the point being,
when you
yeah,
say coins, or do you mean
but
clauses? Like it writes a clause? Is that a coin?
my tokens.
A
A
token.
token is a word. Yes,
Yeah.
a token.
When it
Yeah.
is a token a clause or is it a single digit
No,
or
a word. So each
it's a
word would be
word?
considered a
Okay.
token. Yeah, yeah. So that comes from the natural language processing community, where when you get a body of text, you have to divide it up into different words, and each of these words is called a token. So
Okay.
it's a individual word that you create, and then each of these words is processed individually throughout your whatever your process is for your natural language processing
Mhm.
um, task. So right. So, but these tokens are generated spewed out one at a time, and so it's true. Just choosing the one that's with the highest probability should be
Highest
the next token.
probability.
After saying, the
Right.
black cat jumped, and then the next word would be over, or maybe up, or across, or whatever. And depending on the training set, it would decide which one is the next correct word.
Right. Thinking and
Um,
reasoning
but
machine.
yet yeah,
Go ahead with that part and then I'll
right.
ask you.
So, just yeah, well, I mean, I guess um the main takeaway is that when we talk about thinking machines, we aren't talking about machines that think. We are talking about us imposing
Mhm.
a worldview or types of functionalities turned into capabilities onto these probabilistic token generators. It's not,
Right.
they don't think. That's not
Right.
not what they
The
do.
thinking is inside our head. The processing is inside the machine. Right.
Right. The generation of tokens is in the machine, but how we interpret that, when we say, it looks like this machine is thinking, it's more correctly, it looks to me like I am interpreting the output of this device to give me the impression that I have come to the conclusion that it looks like it could be thinking, but it's not thinking.
Okay. Got it. Reasoning. Is the machine reasoning?
No, absolutely not.
Why?
Absolutely. So, I mean, these are, to a certain extent, it's sort of like a higher level type of trick. So you have training sets where they have problems, and then these problems are subdivided into subtasks. And then there's text that describes how to get from the one subtask to the next subtask. And then you have hundreds of these, maybe thousands of these. And then you train the model to, given this type of input, to create that type of output, given other types of input. So it's going to mimic the token generation scheme that it saw for these reasoning examples, and it's going to try to copy that
Right.
that order of tokens. so that it looks like. Now they have done other types of um, output correction where they will, query the large language model again, or maybe a different model, or a different instance of the same model, and say, does this look like reasonable output given this input? And then that will be some sort of probabilistic method of saying, yes, this looks like it's good, or yes, or no, this looks like it's bad. And then maybe it will reiterate on that given other new type of input in order to hopefully generate a better output. But it's all about input and probabilistic token generation output. There's no thinking. But I think really the next step, the next level of this type of conversation is the people who do think these machines are thinking. What kind of danger is that?
Right.
It's not that
they believe the projection.
The machines, the output of the machines in and of itself, it's just tokens. It's just text. It's text that has been artificially created, mechanically extruded, whatever you want to describe. It's just text. Now, the danger is that someone's going to take this text and say, oh, it's a thinking machine. Oh, it is correct. Oh, I can use this type of automatic text generation to replace someone at work who is essentially an automatic text generator. Right. So that's when the danger begins to happen. Right? The danger isn't in this machine in and of itself. The danger is in how people use these machines and how much of a belief system they create in using these machines and convincing themselves that this level of this type of output is somehow programmatically correct.
Right. Now that goes into the ethics of it. And also, as children go into teenagers, they still don't have reasoning skills that are developed. And so they sometimes still can't make, or they can't yet make analytical decisions about what's going on. So you start seeing a lot of suicides because the AI said you're a worthless person, so you might as well kill yourself. There's like a kind of
I've heard about some of those cases, and that's just horrifically tragic.
I saw something today, something
example.
Like it's called Blue something. I forgot the name of this thing, but anyway, yeah, you've seen it too, right?
Yeah, I believe so. I mean, I've heard about these cases. I haven't actually looked any more deeper, frankly. I've been pretty good at avoiding bad news the last couple of months. So
yeah, I know.
If I see something like that, I make sure.
But anyway, yeah, I think
that
these are examples. These are good examples of the problems. Let's move on to just a question. So say Hinton is the godfather of AI, right?
There's 3 or 5 of these guys who did the deep learning stuff. It's starting in 2012 and so on. Yeah. So yeah.
Let's take Hinton versus Chomsky. Hinton says that that this is communication, that this is language. Where I would say that I would argue from biolinguistics in cognitive science that that's not exactly what's going on, that I'm in agreement with you, because while that might be communication, so is like a bird call to another bird, or a chimpanzee to another chimpanzee. The call and the response is always the same. It's not a creative system. Whereas Chomsky argues like Galileo, where Galileo said, well, we have 26 these characters, and somehow they're put together in almost an infinite array. And so then it goes on to Port Royal, grammar, and then on up to the cognitive revolution and this kind of thing. So it is possible that you can have Chomsky and Hinton as an integral aspect, but Hinton, different than Chomsky, Hinton cuts off the generative aspect of the actual creativity of the language, which then leads me to, and I think obviously leads to the question of, as you said before, human beings are just text generators, just machines. Now we're back into the mechanization of the human being.
Well, I mean, from an ethical point of view, that's correct, and that is hopefully viewed as bad, right? That's a bad thing to do,
I'm arguing against
is
it.
to assume that people are just text generation devices. And the reason that's bad is that the difference between a probabilistic token generator is that and a human being, or even, to a certain extent, there's some other natural animal. You mentioned bird calls or chimpanzees or what have
Whatever.
you. So, but in terms of human beings, the things that makes a human being, the thought process, the communication actually be much more meaningful than this simulated communication of large language model, is that human beings have agency, right?
Right.
We are autonomous. We have desires. We have thoughts, and we have agency. We are capable of acting in our own behalf, on our own behalf. We are capable of acting on behalf of others. We are capable of experiencing things like empathy, right? Where we are able to put ourselves in other people's shoes. We are able to, thereby, we're able to generate communication in a desired format in order for whatever the listener is, our communication partner. And large language models absolutely 100% do not have agency. They have no concept of self. They have no concept of empathy. They have no concept of vicariousness. All of these things are absent in a probabilistic token generator. So the willingness of someone to say, I'm going to replace a person who has agency, who is able to act on not only in his or her own behalf, but on the behalves on behalf of others. Yeah, don't use that word very often. Is ridiculous, right? That whole idea is completely ridiculous. That doesn't make any sense, because if you are replacing a person with a token generator, you are denying the fact that the person, the employee who had agency, that agency was of any value whatsoever. Now, I do believe there are employers out there who absolutely 100% want to do this. They want to fire their employees because they're too expensive, and they want to take that money and put it directly into their or their shareholders' pockets. Okay, but that does not mean that this token generator is as good or as worthwhile or flexible or whatever it is, that is not going to have the same type of quality that a human being with agency is going to have. I think it's just a completely ridiculous sentence.
Right. So it ends up having no meaning. It's, as you said, it's
Yeah,
ill-posed. The whole question's ill-posed.
yeah, exactly. It's ill-posed.
Mhm. We believe not we, but many people believe the projection. Okay, so, and that it could end up being that a human is just a text generator, just a machine. So then they're disposable and replaceable by this text generator, what you call spicy autocomplete. This is actually spicy autocomplete.
Yeah.
Sounds like one of those terms like spooky action at a distance.
Yeah, a little bit. I think it's there's Emily Bender and Alex Hanna. They, for a while on their podcast, they were describing large language models as mathy maths. So if you ever say large language model or AI, just replace mathy math and then see if you still feel the same way about the output that it's creating. It's just a whole lot of large matrix multiplications and calculations and summations. And so, mathy math, if you think that mathy math has agency and is able to do things on behalf of others in an autonomous fashion, then the problem probably lies with you, not with the device. Yeah, so I
Right.
think that's
I
a really
think
good way
there's
of
there's
looking
a
at it.
bit of Wittgenstein here, because even though he in the Tractatus, he talked about that language really is just a bunch of games. It doesn't have any actual correlation with the physical reality, which he backtracked on later. But he did make some good. I mean, we can use the Tractatus as a way into kind of what you just said, that if you use AI, it has a kind of mystical, thing going on with it. You can project humans into it. But if you say mathy math, then it doesn't have this kind of sexy, mystical kind of aspect to it, and it's more accurate in this area. So I think that this can help. We can go away from Wittgenstein and all of that kind of stuff and just go into okay, mathy math. So when I say AI, I mean I want you to think mathy math, okay? Mouthy mouth, mouthy math. I'm trying to get it right.
Mathy math, yeah.
I
So
think that's
yeah,
better
it's
than I think that mouthy math is better than mathy math. But anyway,
yeah, with mathy mouths, all of it works just
mathy
fine.
mouth, right?
Um, well, I think that, and I do think this is actually really a very confusing thing, and I think it's really easy to get yourself caught up in this type of um, I, I don't know, false thought process by virtue that a lot of the philosophy of mind. I'm by far not an expert. I've read some stuff, but it seems like there's an especially in the earlier works there's a almost a one-to-one sort of correlation between the thinking that language is the expression of mind and therefore intelligence, and so that by virtue of the fact that we have created machines that really do language very, very well,
Mhm.
really astonishingly well, that it is very, very easy to say, oh, well, it does language well, it must be thinking. And
Mhm.
so that's why we have to go, a couple of layers deeper and say, well, no, clearly language in and of itself is not enough to represent a theory of mind or a presence of mind or a presence of intelligence. There has to be other things that are involved there that and not just this faked communication. And so it's really easy to get caught up in that sort of mythical belief that well it looks like it's talking. Yeah, well, it's very, very good at the imitation game. So
Yeah.
uh,
Well,
very,
Oliver, thank
very,
you so
very
much.
interesting stuff.
Thank you so much. I'm glad we had a chance to talk about this before I give this lecture. And let's delve into this a little more next time around in a few months, like we normally do. And
Sure.
between now and then, I'm sure things will have advanced quite a bit.
Yeah. Boy, I tell you, things are moving at light speed in so many different areas right now.
Amazing.
I think a conversation in a couple of months will also be very exciting. So
Yeah.
yeah, thank you.
And
Thank you very
humanoid
much for having
robots, we need to go in that direction too. So thanks. I've been speaking with Oliver Sampson, a computer scientist there in Lake Constance, Germany. Cheers.
That's right. Okay, bye-bye.